One of the important question related with given meter bridge. The question is, in the meter bridge experiment, balance point was observed at J with AJ equal to L. If the value of R and X were double and after that they are interchanged, what would be the new position of the balance point? Second question in this case, if galvanometer and battery are interchanged at the position, how will the balance point get affected? इस क्वेश्चन में क्या है कि एक गिवन मीटर ब्रिज है जिसमें दो रेजिस्टेंस R और X है। इस केस में R और X को फर्स्ट ऑफ ऑल डबल कर देते हैं एंड आफ्टर दैट उसको इंटरचेंज कर देते हैं। इनिशियल पोजीशन में लेंथ जो है बैलेंसिंग लेंथ L है। इफ R and X making double and then interchange, what is the value of new balancing length from in A? और सेकेंड क्वेश्चन है कि दिस इज मीटर ब्रिज and corresponding length L be obtained balancing condition. Now this galvanometer and battery are interchanged. Now how the balancing point affected, है ना? इस केस में यही हम डिस्कस करेंगे। In the given meter bridge, this is R, this is X, this is length L and this is length is 100 minus L. Corresponding balance condition, R by X is equal to L. Suppose that resistance per unit length is a smaller, then this length is equivalent to L into R and rest one that is equal to 100 minus L into R. This is one of the equation. Now the value of this making double, this also making double, and after that both are interchanged. It means this become 2R, this become now 2R, and corresponding this change the balancing length, suppose that X. If this balancing length become X, the rest part this is equal to 100 minus X. Again we observe the balancing condition. Now under this situation the value 2X by 2R is equal to X into R upon 100 minus X into R. Our main interest to find out the value of this X. For solving it, this is 2 cancel 1, R cancel 1. Now equation become R by X is equal to 100 minus X by X. Just you observe, this is R by X upon L upon 100 minus L. Second step, we observe R by X equal to 100 minus X by X. From equation 1 and 3, we find that LHS are equal, hence RHS are also equal. Hence, we say that the value of L upon 100 minus L is equal to 100 minus X upon X. Now solving it, Lx is equal to 100 minus X into 100 minus L. Next step, that is Lx equal to 1000 minus 100 L This is clear? Again, this is equal to minus 100 x plus xl. Okay, now this xl cancel one. Our main interest to find the value of x. How we calculate the value of x? Again, 100 x is equal to, we take 100 common. Now this become 100 minus L. This 100 cancel. Finally, x equal to 100 minus L. From this we conclude that if the value of x and r making double, and after that interchange, the result of balancing length also interchange. Initially balancing length is L, rest part 100 minus L. Finally we observe this value become, after interchanging, the value become 100 minus L, just its value interchange. If the question asked in this case कि in this question how the balancing length affected if area of cross section of this given wire is double. You already know the value of R by X is equal to A upon 100 minus L. Okay. The value of R or X, yeah, this equation is independent of area of cross section. It only depends on length. Here there is no change in balancing point after making the area of cross section double. And last part, if galvanometer and battery are interchanged, how the balancing length affected? We observe the value of P by Q equal to R by again S. The ratio R remains unchanged. Hence, there is no effect on balancing length. Clear? This is another question related with meter bridge, in which this is given meter bridge and our question is calculate the value of unknown resistance, this is X, and the current drawn by the circuit, assuming that no current flows through the galvanometer. Assume the resistance per unit length of the wire AB to be 0.01 ohm per centimeter. This is question. Okay. In this case, this is the given meter bridge. This is a known resistance. This resistance is 4 ohm, and this balancing point is 60 centimeter, corresponding with the current through galvanometer, that is equal to 0. This indicates that this is the condition for balance with stone bridge. ये दिया हुआ इसमें है कि ये वायर है, इस वायर का रेजिस्टेंस आपका यूनिट सेंटीमीटर का 0.01 ओम पर सेंटीमीटर है. अंडर दिस कंडीशन व्हाट इज द करंट ड्रॉन थ्रू बैटरी? First of all, for calculating the value of current, we know that I is equal to V by R. V is given. First of all, calculate what is the value of equivalent, what is the value of net resistance of the circuit. Okay. Now, for calculating the value of X, this is given meter bridge. The value of the balance condition is ratio of, that is X by R is equal to P by Q. Suppose that this balancing length is given 60 centimeter. Now rest length, that is equal to 100 minus 60, this become 40 centimeter. Now our interest, how we solve this question. इस क्वेश्चन को हम कैसे सॉल्व करेंगे, है ना? फर्स्ट ऑफ ऑल वी कैलकुलेट द वैल्यू ऑफ x. For calculating the value of x in the given meter gauge, the condition for balance become x by r equal to L upon 100 minus L. The value of x is unknown. X is unknown. The value of r is given, that is equal to 4 ohm. The value of L is 60 centimeter. Value of x we write here, that is 60, and the rest part, that is equal to 40. The value of x is equal to 60 by 40 into 4. This one cancel, this 4 cancel. Your unknown resistance become 6 ohm. This is the value of unknown resistance. First of all, we calculate the value of unknown resistance. Now our interest, how we calculate current drawn from the battery under the balance condition. For this one, again we write here, the value of x is equal to, just we modify the circuit. Next step, this x, that is equal to 6 ohm. Next one, that is equal to 4 ohm. This is also equivalent to resistance because R proportional to L. The resistance per unit length is given. The resistance per unit length, that is equal to 0.0 ohm per centimeter. This indicates 1 centimeter having resistance 0.1. Then what is the value of resistance of the 60? 60 का कितना होगा रेजिस्टेंस? तो 1 सेंटीमीटर का रेजिस्टेंस आपका 0.01 है, इसलिए 60 सेंटीमीटर का क्या होगा? तो 60 इंटू क्या आएगा जी? 0.01. ओके, नाउ वी सॉल्व इट. सॉल्व करेंगे, क्या आएगा जी? एक कैंसिल हो गया. देन दिस वैल्यू बिकम 0.6 ohm. Rest one become, that is equal to 4 ohm, 0.4 ohm, and this is connected with the help of battery. Under the balance condition, no current drawn, hence there is no function of galvanometer. Now our result, this 6 and this 4, that is in series combination, hence modified equivalent become, this is 6 and this is 4. Due to series combination, their value become 10. In case of series combination, you already know R equal to R1 plus R2. Hence net value becomes 10. Now this is 0.6, this is 0.4. Hence the net value of this part 0.6 plus 0.4 is equal to 1 ohm. And this becomes 5 volt. Just you observe, this is 10 ohm, this is 1 ohm, and these two are in parallel. Hence, the equivalent 1 by R is equal to 1 by 10 plus 1 by 1. LCM 10, this is 1. And this will become 10. This is the value of 1 by R. Again 1 by R is equal to 11 by 10. Then R is equal to 10 by 11. This is the value of resistance. Net value of the resistance. It means equivalent circuit become just like this one. This is 10 by 11 and this is connected with the help of battery with potential V. The value of I our main interest to calculate the value of I. The value of I is equal to V by R. In place of V, we write here 5. In place of R, we write here 10 by 11 is equal to 5 into 11 by 10. This one cancel. Your final result 11 by 2 is equal to 5.5 ampere. This is the value of current drawn by the circuit. Just to observe, in the given question, the value of unknown resistance, that is equal to 6 ohm, and when no current is drawn, under that condition, the current drawn through the battery is equal to 5.5 ampere. Okay. The next question of the given meter read is, in a meter read, the balance point is found to be 40 centimeter from end A. If a resistance of 10 ohm is connected in series with R, balance point is obtained 60 centimeter from A. Calculate the value of R and S. First of all, this is R, this is L, and the balancing length, that is equal to 40 centimeter. The rest one is equal to 100 minus 40 equal to 60 centimeter. Now, in the balance condition, R by S is equal to 40 by 60. Result of that, this one cancel, this is 2, this is 3. Now 3R is equal to 2S. The value of R is equal to 2S by 3. According to question, when 10 ohm resistance connected in series, then the value of resistance of this section is equal to R plus 10. Suppose that the value of resistance balancing length is already given. The given balancing length, that is equal to 60 centimeter. Rest resistance, rest length, that is equal to 40 centimeter. Now second one, due to series combination of 10 ohm with R, the resistance become R plus 10 by S is equal to 60 by 40. Now we solve it. The value, this is equal to, this is your 0, 0 cancel, this is 3, this is 3, and this become 2. The value of 2R plus 20 equal to 3S. The value of, putting the value here, putting the value of R in place of R, we write here 2S plus 3, and the rest one, that is equal to 20 is equal to 3S. By solving it, we find that the value of S is equal to 12 ohm. Our again interest to find the value of R. How we calculate the value of R? Now putting the value of S equal to 12 ohm in equation 1, then R is equal to 2S by 3, 2 in place of 3, we write here 12, 3, 12 cancel. Our final result, that is equal to 8 ohm. In this case, if R and S balancing length 40 centimeter, if 10 ohm connected in series, the balancing length become 60 centimeter. Under this condition, the value of unknown resistance, the value of S is 12 and the value of R is equal to 8 ohm. Okay.